What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Glue workflows, step functions, and MWAA, orchestrating data pipelines. Let's get into it. By the end of this video, you'll know exactly which of Amazon Web Services' 3 orchestration services to pick on exam day. And this decision shows up in both Domain 1 and Domain 3. Which together account for more than half the exam. Here's the thing most candidates miss. The wrong choice is almost never wrong because it doesn't work. It's wrong because it costs too much, or it's overkill, or it ignores a one-word clue in the question. Let's fix that. Picture this. You're 90 minutes into the exam and you hit a scenario. A team needs to run a crawler, then 2 glue jobs, then another crawler, every night at 2 a.m. 4 answer choices, all plausible, all working solutions. The trap is that 3 of them work but cost more or add complexity for no reason. Only one is the right answer, and you have about a minute to figure out which. Here's the entire decision tree, and I want you to burn this into memory. Ask yourself one question: what's in the pipeline? If everything is glue, crawlers, jobs, more crawlers, pick glue workflows. It's the cheapest because orchestration is built into glue itself. If your pipeline touches multiple services like glue plus Lambda plus EMR plus SNS, pick step functions. It's serverless and integrates with over 220 Amazon Web Services. Now before we get to that third branch, 2 quick definitions. Apache Airflow is an open-source workflow scheduler that data teams use to write pipelines in Python. Those pipelines are called DAGs, short for Directed Acyclic Graphs. And MWAA is Amazon's managed version of Airflow, so teams can run their existing Airflow code on Amazon Web Services without rewriting it. So if the question explicitly mentions existing Airflow DAGs or Python and Bash scripts that the team doesn't want to refactor, pick MWAA. Notice that third branch, MWAA, is the most expensive option, so only pick it when the keywords force your hand. Straight from the Amazon Web Services Glue docs. The key phrase is at the end, tracked as a single entity. That means one place to monitor, one place to see failures, one place to retry. You're not stitching together separate glue job runs and trying to figure out which crawler ran after which job. It's one workflow object that knows the whole pipeline. Every glue workflow starts with one of 3 trigger types. A schedule trigger fires on a cron expression, like every night at 2 a.m. An on-demand trigger waits for you to kick it off manually. And an EventBridge trigger lets the workflow start in response to an event, like a file landing in S3. Once the workflow starts, you can chain crawlers and jobs together using conditional triggers. So a crawler runs, then ETL job 1 runs, and only when job 1 finishes successfully does job 2 kick off, followed by a final crawler to update the catalog. And here's the powerful part. Conditional triggers can fire on success, failure, or timeout, so you can build error handling right into the pipeline without ever leaving glue. This is the part candidates miss. Step functions costs money per state transition. MWAA costs money for an always-on environment. Glue workflows costs nothing extra, you're already paying for the glue jobs themselves, and the orchestration layer is free. So when the exam mentions cost as a primary concern on a glue-only pipeline, the answer is almost always glue workflows, full stop. Step functions is the default answer the moment your pipeline crosses a service boundary. Under the hood, it's a serverless state machine. You define your workflow in Amazon States language. That's the JSON format Amazon Web Services calls a SL, or you drag and drop in Workflow Studio, the visual editor. Built-in features include retries, error handlers, branching with choice states, parallelism with parallel and map, and even human approval gates for pipelines that need a manager to click yes before production data ships. The killer feature, though, is integrations. Step Functions talks to over 220 Amazon Web Services natively. In concrete terms, that means Glue for ETL, Lambda for short functions, EMR for big data clusters, SageMaker for machine learning, ECS for containers, DynamoDB for fast lookups, and SNS for notifications. That combination is why Step Functions is the orchestrator you reach for whenever more than one Amazon Web Services service is involved. Step Functions comes in two flavors, and you pick one at creation time. You cannot change it later, which the exam loves to test. On the left, standard workflows run for up to a year, give you exactly once execution, bill per state transition, and keep 90 days of execution history. They support two integration patterns you need to know by name. With .sync, Step Functions pauses and waits for the called service to finish before moving on. With .waitForTaskToken, it pauses and waits for an external system to send back a token confirming the work is done, useful for human approvals or third-party systems. Pick standard for long ETL jobs with EMR and anything that needs an audit trail. On the right, express workflows are capped at 5 minutes and deliver at least one semantics. Billing is by duration and memory, not per state transition. They can crank through up to 100,000 transitions per second, but they only support request response, no .sync, no callbacks. Pick express for high-volume, short-lived event processing, like reacting to a flood of API calls. This is the exact wording from the Amazon Web Services docs, and I want you to memorize the two qualifiers. Standard is for long-running, durable, and auditable. Express is for high-volume, event processing. If the question says auditable or durable or long-running, that's standard. If it says high-volume, event-driven, or short-lived, that's express. Amazon Web Services wrote this comparison table to make the exam answer obvious. Let it. Here's a Step Functions feature the exam loves: the map state. Think of a restaurant kitchen. Instead of one chef cooking 10,000 plates in sequence, you hand each cook one plate and they all cook simultaneously. Map state does the same thing for your data. There are two modes. Inline map runs in the same workflow execution, giving you up to about 40 parallel branches and 25,000 history events. That's fine for small to medium fan-out. But when the exam describes processing thousands of files from an S3 bucket in parallel, you want distributed map. Distributed mode runs up to 10,000 parallel branches and is specifically optimized for iterating over S3 objects. So when you see the keywords parallel processing of thousands of S3 files, the answer is Step Functions with a distributed map state. Read this quote carefully, because it's the entire reason MWAA exists. MWAA runs the same open-source Apache Airflow you'd install yourself. So if your team already has Airflow DAGs written in Python, you drop them in an S3 bucket, MWAA syncs them to its scheduler every 30 seconds, and they run unchanged. No rewrite, no porting, no learning a new DSL, that's the whole pitch. This is a keyword trap, and it's brutal. MWAA is the most expensive of the three orchestrators because it runs an always-on environment: scheduler, workers, web server, the whole Airflow stack. So unless the question explicitly mentions existing Airflow DAGs or migrating Python and Bash scripts without refactoring, MWAA is the wrong answer. Real teams confirm this constantly. When their pipelines run hourly or less frequently, they migrate away from MWAA to Step Functions plus Lambda because the cost doesn't justify it. Let's put them side by side. Glue Workflows is cheapest because orchestration ships with Glue. Its scope is narrow though, only Glue jobs and crawlers. The languages are whatever you write in Glue, mostly Spark and Python. Best for pure Glue ETL chains, end of story. On the right, step functions is serverless, pay-per-transition, integrates with 220 plus Amazon Web Services, and you build it visually or in ASLJSON. MWAA is the heaviest, an always-on Airflow environment, the most expensive choice, but the only one where your existing Python DAGs run completely unchanged. Pick the cheapest tool that fits your actual requirements. Think of EventBridge as the nervous system of your Amazon Web Services account. It's a serverless event bus. Every service can send a signal, and EventBridge routes it to the right target, whether that's Glue, Lambda, or step functions. The first major piece is EventBridge Scheduler, which handles cron and rate-based schedules, and it's the modern replacement for CloudWatch events. You may see CloudWatch events in older documentation or legacy exam questions. Treat it as the old name for the same scheduling concept. The second piece is event routing. EventBridge reacts to S3 events, Glue job state changes, EC2 events, and custom events from your own apps, firing the right target automatically. The canonical exam pattern ties it all together. A cron expression, cron02**, firing a nightly Glue job at 2 a.m. UTC. On current exams, EventBridge Scheduler is the right answer for any cron-style trigger. S3 event notifications is the most common pipeline entry point on the exam. When a file lands in S3, you want something to happen. S3 supports 3 direct destinations. Lambda for direct compute, your function fires immediately with the event payload. SQS for a buffered queue, useful when you need to handle bursts or process events at a controlled rate. And SNS for broadcast fan-out when one event needs to go to many consumers. Now, one quick aside before the gotcha. SQS has 2 flavors, standard and FIFO. SQS FIFO queues guarantee messages are processed in the exact order they arrive, and they're never processed twice. That matters when sequence matters. Think financial transactions where you must apply a deposit before a withdrawal. And here's the gotcha that catches people. S3 event notifications do not support SQS FIFO queues directly. If you need that ordered exactly once processing for S3 events, you have to route through EventBridge first. Here's the fan-out pattern Amazon Web Services officially recommends. Imagine an e-commerce order pipeline. A producer publishes one order-placed event to an SNS topic. SNS broadcasts that single event to multiple SQS queues, one for inventory, one for email, one for analytics. And on the right, each consumer reads from its own queue independently. The reason you put SQS between SNS and your consumers is durability. If the email consumer crashes for an hour, the messages wait safely in its queue. The inventory consumer keeps processing without interruption. Each queue gets its own dead letter queue for failures, and each consumer scales on its own. When the exam says one event must trigger multiple independent downstream pipelines, this is the answer. Here's the quickest way to keep SNS and SQS straight. SNS is a radio broadcast. Anyone tuned in hears it the moment it airs, but if your radio is off, you miss it forever. It's push-based, fans out to many subscribers, doesn't retain messages, and you use it for alerts and broadcasts. The exam keyword is notify multiple consumers. SQS, on the other hand, is a voicemail box. Messages wait patiently until you check them, and if you crash mid-listen, you can replay. It's pull-based, buffers bursts, durable with visibility timeout and dead letter queues. The exam keywords are decouple, buffer, and retry on failure. Lambda is the duct tape of Amazon Web Services. Perfect for small, quick fixes between services. Convert this file, validate that schema, kick off the next job. But duct tape can't hold up a bridge. When your job runs more than 15 minutes or needs more than 10 gigabytes of memory, you need real steel. Glue, EMR, or ECS. The exam will absolutely test this. If the scenario describes a terabyte-scale transformation and one of the answers says Lambda, that answer is wrong on principle. Lambda operates within hard limits: a 15-minute timeout, 10 gigabytes of memory, and 10 gigabytes of ephemeral storage. Within those limits, it shines in data pipelines. File format conversion is the classic pattern. A CSV lands in S3, S3 fires an event, and Lambda converts it to Parquet using the Amazon Web Services SDK for Pandas, also called Amazon Web Services Wrangler. That's an open-source Python library that wraps Bota3 and makes reading and writing Parquet to S3 from Lambda much simpler than doing it manually. Schema validation is another sweet spot. Reject malformed files at the door before they pollute downstream tables. Lambda is also the natural trigger for downstream jobs. It can kick off a Glue job, start a step function's execution, or submit an EMR step. And it handles pipeline notifications beautifully, formatting Slack or email alerts when an upstream stage fails. Past those hard limits, though, you've outgrown Lambda and need Glue, EMR, or ECS instead. These are the traps exam writers love. First, step functions on a Glue-only pipeline. Glue workflows is cheaper. Second, MWAA when there's no Airflow mention, the most expensive wrong answer on the exam. Third, Express when you need .sync or .waitFor task token. Express is request response only. Fourth, Lambda writing back to the same S3 bucket. It reads from an infinite loop cost spiral that explodes your bill overnight, so always write to a different bucket or prefix. Fifth, S3 events routed directly to an SQS FIFO queue. Not supported, you have to go through EventBridge first. Memorize these 5 and you'll spot the wrong answers instantly on exam day. Let's walk through a real scenario. The question describes 5 Glue jobs and 3 crawlers that must run nightly in a specific order with cost as the primary concern. Read the keywords: Glue jobs, crawlers, specific order, cost. Every component is Glue, no Lambda, no EMR, no SNS, so the answer is Glue workflows with a scheduled trigger. Step functions would work, but it adds cost. MWAA is wrong because the question never mentions Airflow, and it brings always-on environment costs. Stitching together Lambda and EventBridge per job would work too, but it's brittle and has no native dependency tracking. Glue workflows wins on cost and simplicity. That's the pattern. Here's everything in one slide. Glue-only chain, Glue workflows cheapest. Multi-service pipeline step functions. Existing Airflow DAGs, MWAA cron schedule, EventBridge scheduler. S3 file drop, an event notification to Lambda, SQS, or SNS Fan-Out, SNS into multiple SQS queues. Parallel thousands of S3 files, step functions, distributed map. Burn these 7 rules in, and orchestration questions become free points. Now let's test what you've learned with a quick 5-question quiz. Alright, let's test what you've learned. Question 1. A retail company runs a nightly pipeline consisting of 3 Glue crawlers and 4 Glue ETL jobs in a specific order. Cost is the primary concern. Which orchestration service should they use? Is it A, AWS Glue workflows with a scheduled trigger? B, Amazon MWAA, AWS step functions standard workflow? Or D, AWS Lambda chained via EventBridge rules? Take a moment to think about it. The answer is A, every component is Glue, crawlers and jobs only, and cost is the primary concern. Glue workflows has no extra orchestration cost because it ships with Glue itself, making it the cheapest answer for Glue-only pipelines. Question 2. A data team needs to process 50,000 CSV files sitting in an S3 bucket in parallel, applying the same transformation Lambda function to each. Which is the most appropriate solution? Is it A, step functions standard workflow with a parallel state? B, step functions with a distributed map state? C, step functions with an inline map state? Or D, glue workflows with parallel job triggers? Take a moment to think about it. The answer is B, inline map is capped at around 40 parallel branches, which won't cut it for 50,000 files. Distributed map supports up to 10,000 parallel branches and is specifically optimized for iterating over S3 objects. It's the canonical answer for the parallel file processing scenario. Question 3. A team is migrating from self-managed Apache Airflow on EC2 to AWS. They have 40 production DAGs written in Python that they want to run unchanged on AWS. Which service should they choose? Is it A, AWS step functions rewrite the DAGs in Amazon states language? B, AWS glue workflows recreate each DAG as a glue workflow? C, Amazon MWAA drop the DAG files in S3 and they run unchanged? Or D, AWS Lambda convert each DAG to a Lambda function? Take a moment to think about it. The answer is C, MWAA runs the same open source Apache Airflow, so existing DAGs run without refactoring. You just drop the .py files in S3 and MWAA syncs them to the scheduler. The keywords existing DAGs and unchanged point directly to MWAA. Question 4. A single order-placed event must trigger 4 independent downstream systems: inventory, email notifications, fraud detection, and analytics. Each system needs its own retry policy and dead letter queue. What is the recommended architecture? Is it A, S3 event notification fanning out to 4 Lambda functions directly? B, EventBridge rule with 4 Lambda targets? C, SNS topic with 4 SQ subscribers, each consumed independently? Or D, step functions parallel state invoking 4 branches? Take a moment to think about it. The answer is C, the SNS to SQS Fan-Out Pattern is a WSS official recommendation. SNS broadcasts the event once. Each SQ gets its own copy with independent retry policies and dead letter queues, and consumers process at their own pace. This decouples the systems and provides per-consumer durability. Last question. A team has a step functions workflow that orchestrates a long-running EMR job. The workflow must pause until the EMR job completes before moving to the next state, and they need a full audit trail of every execution for 90 days. Which workflow type should they use? Is it A, express workflow because it's cheaper per execution? B, standard workflow because it supports .sync and keeps 90-day execution history? C, either type, the workflow type can be changed after creation if needed? Or D, express workflow because it supports the .waitFor task token pattern? Take a moment to think about it. The answer is B, standard workflows are the right choice for 2 reasons. First, they support the .sync integration pattern, which lets step functions pause and wait for the EMR job to finish. Second, standard keeps 90 days of execution history, which satisfies the audit requirement. Express workflows are capped at 5 minutes, only support request response, and have much shorter history. And remember, you pick the workflow type at creation, and you cannot change it later. And that's a wrap on glue workflows, step functions, and MWAA, orchestrating data pipelines. If this helped you out, smash that like button and subscribe for more. See you in the next one.